So as you have been looking the ways of solving quadratic equations, we started with the first one that using the factor method. Now we are moving to the second one, which is completing square method. We'll try to see on our whiteboard. Completing square method, we're going to be moving together. Consider the identity x plus b squared. When you expand it, it means it's going to appear 2 times. You come out with x squared plus 2bx plus b squared. It indicates that adding the term b squared on this one here, adding b squared on this to the expression this, it is going to make it a perfect what? Square, so that it can easily be factorized. But when you don't add the b squared, it can't become a perfect square. So that's what we are coming to this. The procedure involves the procedures which are going to be using when we are completing square. The first one is x squared must have a coefficient of 1. Even if you find that x squared has a coefficient of 5 or 2, first divide it out by 2 throughout to make sure that x squared bears a coefficient of 1. I'm repeating this one, we don't complete square when x squared is having a coefficient which is more than 1. So x squared must have a coefficient of 1. Then the completing square will go on. Then from there, the coefficient of x like here is x squared. We've already said that for computing square take place, x squared must have a coefficient of 1. Then to the coefficient of x, it is always being divided by 2. So we add a half to it, as you're going to be looking in our examples, which you're going to be taking on that. So the first one I will say express, example 1, express x squared minus 5x plus 8 in the form of x plus a squared plus b. First express x squared minus 5x plus 8 in the form of this one. So can this one, when they say in that form, they are meaning apply completing square method. So what we're going to do is this, x squared minus 5x plus 8 equals, now you can see x squared has already a coefficient of 1. That means we are free to go on with the idea of completing our square. Then with the coefficient of 5x, we said on that one, you divide it by 2. So what we're going to have, x squared minus 5x, we say out of 2. What you have done, you also add on it, say plus 5 out of 2, the whole of it, but then what is a negative? We say plus that negative squared, then there is also a plus 8. So from there, what do you write? We are only going to write, this one is already a perfect square, we shall only write x minus that one as it is, minus 5 out of 2, the whole of it squared. What does it mean? When I expand the whole of this one, I will come out with this. Then I say plus 8. So since I've said we put it in that form, it is the same as x plus negative 5 out of 2, the whole of it squared, then plus 8. If they say, hence state the values, I'm free to say, therefore, A equals that, B equals that. So that's what we normally do to this. So I've already expressed that one. So we are going to be using the same ideas to solve the following, or to solve the following on that. So if we move on, we have already said that after doing that, we have only added it to that. We still add it here, plus, when the expansion becomes 25 out of 4. So after subtracting, such that when you add, the same goes on. So when you find the LCM here, what does it become? What is the LCM here? Got x minus 5 out of 2 squared plus, what is the LCM is 4. 4 divided by 1, we are getting a 4. 4 times that, we are getting 32 minus 25. So what does it become? X minus 5 out of 2 squared plus 32 minus 25, we are getting 7 out of 4. So this one is already expressed in this form which they want. I can even say which is in the form of x plus a squared plus b. So when you compare, it means a equals negative 5 out of 2 and our b equals 7 out of 4. That's what happens to that. If they say express that in terms of that, that's what will automatically come out. So let's take now with examples of solving. That one was about expressing. Let's start with it and say using completing square method. Solve the presence at a x squared minus 7x plus 10 equals 0. So what I'm going to do is this. Now the upset is equal to 0. What you do, you can first take this one to the other side. Take this one in the other side. It's going to be x squared minus 7x equals 8 is a positive because it comes a negative. So we said on the coefficient of x, you divide it by 2. Again, you add it on both sides. So what I'm going to do, this is going to be x squared minus 7 out of 2 x. Then what you do, you add that one, the way it is, plus negative 7 out of 2, the whole of it squared. Whatever you have done here, you need also to do it in the other side. It becomes negative 10 squared. So this one is already now our perfect t. So what do we write? We only write x minus 7 out of 2, the whole of it squared equals negative 10 plus, this is 49 out of 4. So we get the LCM. What is the LCM here? Is 4. 4 divided by 1, you get a 4. Times the 10, you get negative 40 plus 4 divided by 4, you get 1. Times that, you get 49, which becomes 9 out of 4, which is equal to x minus 7 out of 2, the whole of it square. Then, how can we remove this square root? How can we remove this square? Is by taking the square root. This one disappears with that. So we are going to remain with x minus 7 out of 2 equals, what is the square root of that? The square root is plus or minus 3 out of 2. This one is a negative. When it goes there, it becomes a positive. So x equals 7 out of 2 plus or minus 3 out of 2. What does it become? The LCM is already. That means x equals, you can even add 7 out of 2. And start by saying either x equals 7 out of 2 plus 3 out of 2, or x equals 7 out of 2 minus 3 out of 2. We go ahead. For the first one you add, what does it become? This plus this, you get 10 out of 2, which is equal to 5. For this one you subtract. Since the denominator is the same, we just subtract the numerator. 7 minus 4, 7 minus 3, get 4 out of 2, so our x becomes 2. Therefore, x equals 5 and x equals 2. We have already solved that one. So we are going to go on and vote. That was part A of the example.